Hello viewers, welcome back to my YouTube channel. Today we are going to look at electric field. Now this electric field is an example of force field. And what are force field? They are forces which do not require contact to the body to which they are what? Applied. For example, we have gravitational field, we have electric field and magnetic field. So let us see what is electric field. Electric field is a region where a charged body experiences an electric force. Any region where a charged body experiences an electric force, it is said to be what? The field. Okay? So these charges we are looking at can be investigated. This field we are looking at can be investigated using a test charges, using a test charge. And before we go into this electric field, we need to know what is an electric lines of force, how these lines of force move when they are together. Electric lines of force is a path which an isolated small positive charge would follow if placed in the field. Now, the path in which this isolated positive charge will follow if placed in the field is said to be the electric lines of force. For example, we have charges that are positive and we have charges that are negative. So we need to know how they move. Okay? Take for instance, an isolated small positive charge is going to radiate outwards. It's going to radiate outwards. Okay? Then isolated negative charge is going to radiate inwards. And when we talk about attraction and repulsion, so you see something like this. When two unlike charges, they are going to attract. So this is what? Attraction. Because you have two like charges. What that is important here is for you to know the direction of the arrow. Isolated positive charge, it radiates what? Outwards. When negative charge radiates what? Inwards. So when you look at attraction, you'll find out that for positive charge is going out. Then it starts only from positive charges and end only on what? Negative charges. In a situation whereby they will remove this and put what? P. Then this one is what? Q. They will ask you which one is positive. P is positive, Q is negative. You can know that if you're able to understand this concept of the direction of the lines of force, how they travel. I hope you get it now. So the conclusion for this aspect is that the isolated positive charge radiates outwards, meaning that it goes what? It goes out. While the isolated negative charge radiates what? Inwards. If you consider 2-point charges, there is an electric force or there is a force between these 2-point charges, and that force is proportional to the product of the what? Charges, and inversely proportional to the square of the distance separating the two charges. For example, if you have these point charges plus Q and we have what? Minus Q, there is a force that is directly proportional to the product of these charges and inversely proportional to the square of the distance separating these charges. And that gives us what to call what? Coulomb's law. So let's look at the law and explain how we can use it to solve problems. Coulomb's law states that the electric force between 2-point charges Q1 and Q2 separated by a distance r is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. For example, we have these 2-point charges. There is a force that is proportional to the product of this one and this one, and inversely proportional to the square of the distance separating them. The first charge is Q1, the second one is what? Q2. So we say that this force is directly proportional to what? Q1 and Q2, and inversely proportional to the square of the distance separating them. That is over what? R square. I hope you get it now. So this is the equation of what? Coulomb's law. Now this Coulomb's law is also an example of an inverse square law. What do we mean by inverse square law? Because it have inversely what? Proportional. We can otherwise say that F is proportional to what? Inverse of what? R square. Okay, so this automatically made it to be what? An inverse square law. Including law of universal gravitation is also an inverse square law. So let us explain this Coulomb's law and see how we can use it to solve problem. Stay tuned. From Coulomb's law, we have that F is directly proportional to Q1 Q2 over R what? Square. We have to remove this proportionality sign and introduce a constant by saying that F is equals to KQ1 Q2 over R what? Square. So let us state what these parameters means. So the magnitude of the force F is equals to what? Force measured in Newton. Q1, Q2, they are what? Charges measured in coulombs, and R is distance measured in meters. Now we have a constant K. We call it what? Electric constant. We can call it electric constant. Now this electric constant can also be written as what? K is equals to 1 over 4 pi epsilon what? 0. 1 over 4 pi epsilon 0. Epsilon 0 means permittivity of free space, and it is given as 9 times 10 raised power what? 9. The value is 9 times 10 raised power what? 9. So let us generate the unit of K by making the K the subject of formula in this equation. So we have that we have that F is equals to K Q1 Q2 over R what? Square. We are going to say this is over 1 cross multiply because I want to make K the subject. So we say K Q1 Q2 is equals to F R what? Square. I'm going to divide both sides by what? Q1 Q2. Okay, so I have Q1 Q2 Q1 Q2. When I cancel, my K is equals to FR square over what? Q1 Q what? Q2. So we can generate the unit of what? K. F is measured in what? Newton. Radius is measured in meters. I'll have meter what? Square. Charges are measured in what? Coulombs. I will have coulombs what? Square. So this is how we can generate the unit of what? K. And remember that the value of K, which is the same thing as 1 over 4 pi epsilon 0, is equals to 9 times 10 raised to power 9. I'll now input the unit Newton meter square per coulomb square. I believe you know why we have per coulomb square, because this coulomb is in the denominator. So once it comes up, we're going to carry a negative what? Sign. I hope you understand that. So let's see how we can solve problem using what? This electric force formula. Now, if you are watching this channel for the first time, if you are new in this channel, please give it a thumbs up. Subscribe for more educative what? Videos. When you subscribe, other students can also what? See it and learn from there. So let's look at this example on the board. Find the force of repulsion between two protons of 1.6 times 10 raised to the power of minus 19 coulombs each if the distance between them is 5.3 times 10 raised to the power minus 11 meters. Take 1 over 4 pi epsilon 0 as what? 9 times 10 raised to power minus 9 Newton meter square per coulomb square. For us to be able to solve this kind of problem, what you are going to do is to state our parameters. Okay, so we are looking for the force, this question mark, and if they say two protons, that means we have the first charge as positive, the second one as what? Positive. They are not going to attract. That is why they say the force of what? Repulsion, because they are not attracting. So Q1 is equals to Q2 and is equals to 1.6 times 10 raised to power minus 19c. The distance between them is 5.3 times 10 raised to power minus 11 meters. Then K, which is the same thing as 1 over 4 pi epsilon 0 is equals to 9 times 10 raised to power 9 Newton meter square per coulomb square. Let's use our formula, which is F is equals to KQ1 Q2 over R square. What is my K? 9 times 10 raised to power 9 times 1.6 times 10 raised to power minus 19 times 1.6 times 10 raised to power minus 19, then divided by what? My radius is 5.3 times 10 raised to power minus 11 all squared. Okay, so with the help of our calculator, so we have 9 exponent 9 times 1.6 exponent minus 19 times 1.6 exponent minus 19 is equals to what? Is equals to 2.304 times 10 raised to power of minus 28 divided by, let us square the radius or the distance. So 5.3 exponent minus 11 all squared. So we have 2.809 times 10 raised to power minus 21. Okay, so let us divide it. 2.304 exponent minus 28 divided by 2.809 exponent minus 21 is equals to 8.20 times 10 raised to power minus what? 8. So this is how we can solve for the electric force in this particular question. So let us look at this second example. Find the force of attraction between two equal but opposite charges of 2 times 10 raised to power minus 6 coulombs if the distance between them is 25 centimeters. Now this force you are looking for is the force of attraction because the charges are equal but what? Opposite. It means if one is positive, one is what? Negative. So let us state our parameters given. We are looking for the force. The Q1, they are what? Equal, which is given as what? 2 times 10 raised to power minus 6 coulomb. Then the distance between them is 25 centimeter. You must look at this unit. This is supposed to be in meters and not in centimeter. So we're going to divide by what? 100. 25 divided by 100 is going to give me 0.25 meters. Okay, then my K, we all know that is constant. 9 times 10 raised to power 9 Newton meter square per coulomb square. So let's use the formula to find the force. The F is equals to KQ1 Q2 over R square, which is what? What is my K? 9 times 10 raised to power 9 times 2 times 10 raised to power minus 6 times 2 times 10 raised to the power minus 6 divided by 0.25 all squared. Okay, let us multiply 9 exponent 9 times 2 exponent minus 6 times 2 exponent minus 6 is equals to 0.036. Okay, let us square the distance. 0.25 all squared, we have 0.0625. So let's divide it. 0.035 divided by 0.0625. I'm going to have 0.56 what? Newton as my electric force of what? Attraction. I hope you understand. Alright, so I'm going to put up an assignment so that you can solve it and drop your answer in the comment section. The more you solve, the more you understand physics better. If you are joining us for the first time, please do well to subscribe to this channel for more educative videos. See you next time in my next class. Bye.